All right, guys, this is an extension on the absolute value notes we took on Tuesday. Now, just to recall, we went over the actual definition of absolute value. We tried a few examples of absolute value equations in one variable and used a number line to help us create those equations. So this is a bit of a deeper dive, and this is going to be self-guided, but I will pause from time to time to add in some supplemental help based on the slides. Okay, so as I navigate through these slides with you, you will be seeing a supplemental video here and there where I'm going over similar examples so you can have the support that you need to finish with this. Okay. So slide one is just asking you what you remember about absolute value. This is open-ended. There is no right or wrong answer. I am looking for academic vocabulary. I am looking for complete sentences. Other than that, the sky's the limit on this one. Let's go to slide two. This is just going to be a quick warm-up. You will evaluate each absolute value expression below. That should take you only about 2 minutes. And again, if you need any help at any time, I highly recommend reaching out to your Padlet groups. Now, remember, I will monitor those Padlet, group-specific Padlets for interaction and collaboration during this activity. If it's a little thin and a little anemic, I will send out some specific emails to students asking, why are you not utilizing this useful collaboration tool? Again, because that's really what all we have when we're in the asynchronous moments, right? Okay, so slide three allows you to manipulate some things based on the question that it's asking. I'm not going to go any further on this one. It's pretty self-explanatory. Sammy's house is on Main Street, 4 blocks from the police station. That's the sheriff's star right here, and that happens to be at 0. What a coincidence. Move the points to show possible locations where Sammy might live. I'm interested to see what you come up with. Now that you've done slide 3 and manipulated those points that represent Sammy's location, I ask you a question. The equation, the absolute value of x equals 4, describes the possible locations for Sammy's house. Explain why this works. Again, I need you to dig deep, use academic vocabulary, consider the definition of absolute value before you answer this question. If you need to look at your notes, that's okay. I highly recommend doing that. Okay, so this is going to be your first pause, and I will be adding the first supplementary video to help you along with this. We're going to be using a number line to create our equations. Okay, as discussed, this is going to be the first supplementary part of the video where I give you an example of solving an absolute value equation. Now we have the absolute value of x is equal to 3. Well, let's just review really quickly what we talked about on Tuesday. What is the definition of absolute value? Absolute value. The distance, and that is a key word, it's the distance. The distance, a number or an expression is away from 0 on a number line. Okay, key words here. Distance, number line. Okay, well, let's draw a number line. Since the definition applies the number line, let's utilize it. Okay, so there's 0, there's a number line. This is saying that x could be 3 units away from 0. Well, how many different ways can you be 3 units away from 0? Let's think back to the slides. How many different ways could, what was his name? Sammy, how many different ways could Sammy be 4 blocks away from the sheriff's station? Same exact concept. Well, in our specific example here, we want X to be 3 units away from 0. Well, you can be 3 units away from 0 that way, but you can also be 3 units away from 0 in another direction from 0. And that's at -3. So these are the places that X could reside. And therefore, what you have is that X is at -3 or X is at +3. All right, now it's time to continue the Desmos activity. Okay, at this point, you should have done slide 5 and 6 after watching my supplementary video on modeling one of those simple absolute value equations for you. Now we're going to go a little bit further. Okay, so Gemma's house is on Main Street, 4 blocks from the hospital, located at 3 on Main Street. Now, Main Street is the number line. 3 is not 0, so we're not starting from a distance of 0. Move the points to show the possible locations where Gemma might live. We'll leave this up to you. There are 2 points here that you can manipulate. What does it mean to be 4 blocks away from the hospital? Now we are looking at the absolute value of X minus 3 equals 4. Why does this make sense in this situation? Again, there's no right or wrong answer, but I want you to apply what we've already talked about and apply the knowledge you've gained from Tuesday, as well as the from the slides previous this one, to come up with something applying academic vocabulary. Best of luck to you. Okay, so on slide 8, they asked why the equation, the absolute value of X minus 3 equals 4, makes sense for the situation. Well, at this point, you should have placed some markers that represent Gemma's location. So let me just quickly recreate that in our scenario. Now, you're told that Gemma is 4 blocks away from the hospital. But the hospital in this case, as it was in the case of the sheriff's station, is not located at 0 on Main Street, or in this case, a number line. It's located at 3. So there's the hospital. And you need to place markers that are 4 blocks away from the hospital, not 4 blocks away from 0. Well, that's not too hard to do. I can count out 4 units this way. 3, 4, 5, 6. So it looks like it'd be at 7, or 2, 1, 0, or -1. So this is where Gemma could be. And again, Gemma's location is represented by X. How do we know that these values are correct? You can always plug it back in. Let's plug in -1 for X. Is this statement true? Is -1 minus 3 equal to +4? Let's simplify and find out. What is the absolute value of -4? It's actually +4. So that checks out. Let's try the other possible location for Gemma's house. 7 minus 3, we simplify. That's 4. The absolute value of 4 is indeed 4. So we have 2 values that satisfy the equation. All right, moving on. So Paul also lives on Main Street. This is a popular street. His house is 6 blocks from the grocery store, located at 1 on Main Street. So we've already got a position marker for the grocery store. What are the possible locations for Paul's house? Show by moving the points on a number line, and then it asks you, can you write an absolute value equation that works with the situation? Now, before you get too far into the struggle, utilize what we talked about already. I'd like you to pause the video now and try this out. Okay, so we should have gotten something like the absolute value of x minus 1 is equal to 6. So in your own words, explain what the 1 and 6 represent in this equation. Now, what if a classmate wrote the equation as 1 minus x, the absolute value of 1 minus x is equal to 6? Would it still make sense for the situation? I need you to explain your reasoning here. Again, pause the video and give it a shot. Okay, so we're at slide 11. For any absolute value equation, we can write two related equations since we can be talking about the forward or backwards distance from the anchor point or the starting point. In Paul's case, the anchor point was 1, and the distance from 1 in both directions was 6 units. If we were to solve the equation, the absolute value of x minus 1 equals 6, we could solve the two related equations. Now, example 1, or equation number 1, you have x minus 1 equaling positive 6, and 2, negative quantity x minus 1 equaling positive 6. Now, that is definitely one way to view it. I am going to show you in the other supplementary video right now a different way to visualize this. Okay, so here's an alternate way to visualize this and set up these equations. We have the absolute value of x minus 1 is equal to 6. Well, what is the definition of absolute value? Let's apply that to this specific equation, and I'm going to write a complete sentence in doing so. X minus 1, the expression x minus 1, is 6 units away from 0 on a number line. Do you see how I'm applying word for word the definition of absolute value to this specific equation? Okay. Well, where can x minus 1, the expression x minus 1, be located then? Well, it could be located at positive 6, right? Or you could be 6 units away from 0 in the opposite direction, which ends up being negative 6. And once you visualize this, and once you're able to place where that expression lies, you have all you need to create your equations. Here is a case where x minus 1 is at negative 6. Or here's a situation where x minus 1 is at positive 6. All that there's left to do now is solving and checking. Pause the video and try that. All right, you should have solved both equations for x. Adding 1 to both sides. So those are the possible values for x in this situation. How do we know we got that? Let's plug it in. Negative 5 minus 1. The absolute value of negative 5 minus 1, does that equal 6? Well, simplifying quickly shows you that yes, indeed. The absolute value of negative 6 is positive 6. Or does our value x equals 7 work? Let's find out by plugging it in. 7 minus 1 inside the absolute value symbol is 6. And the absolute value of 6 is indeed 6. So we know we've got the right solutions. Okay, now we're at slide number 12. You should have just finished up the supplementary video for the absolute value equation x minus 1, absolute value of x minus 1 equals 6. Let's go ahead and apply that to the next couple of slides. I wish you the best of luck. I wish that you would be collaborating with your small groups in Padlet, and we'll see what we come up with. This last slide is not mandatory. It is a challenge equation. I recommend giving it a shot. You will not be graded on this, but if you get it right, I will put 2 extra points towards a upcoming quiz. In the last equation, the absolute value of 5x plus 10 equals 30. The anchor point isn't 10. Think about your solutions and their graph. What is the anchor point? How could we find that from the absolute value equation? I'd like to see complete sentences here, and I'd like to see academic vocabulary, and I'd like to see you applying the definition of absolute value that we kept working with throughout this activity. This has been the asynchronous section of absolute value. I hope you guys did well, and I will give you feedback by Friday. Take care.